So I told you how to predict geometrically that the least square problem. So you can predict them, that is the error vector connecting B should be perpendicular to the to your original B. So here you have an vector A, that is original vector column vector, and E, and what will be E? E will be the actual error between the actual B and what you have estimated B. So if estimated B, if this estimation is equal to B, that means we have a solution. Otherwise, this will be, you'll be having certain amount of error. And X cap A, that is A transpose. How do you check the orthogonality? A transpose and the value E should be equals to 0. So the same thing we are checking here. So if I expand that, A transpose B and minus A transpose X cap A, so you are getting A transpose B, and here A transpose uh, A transpose into A trans, this is A transpose B, and what is X cap? X cap was from the least square method, A transpose B divided by A transpose A. So if I have this, you can check here. What happens? This is A transpose B. Here also we are left with A transpose B. So A transpose is cancelled, A is cancelled, you are left out with A transpose B. So A transpose B minus A transpose B gives you 0. So that means what? Both are error vector and the original vector are orthogonal to each other. Least square problem is several variable. That we saw the previous example when we had only one unknown and you had many equations. Now look at this problem. You have many equations. That is, you have many equations and also many unknowns. So that time what you will be having, A as a automatically a square matrix, or M by rectangular matrix, M by N. So you have M by N. What will be error? That matrix Ax minus D, that will be your error, and you try to keep this error to a minimum. And how do you do that? Same thing with the differentiation of this square. That is the point when the differentiation of this error vector is equals to 0, nearer to 0. When you equate it to 0, that point of x and the unknowns, we call it as a actual solution, or the values of x1, x2, x3. Similar to a projecting. So to find out x cap, how do you do that? We saw it is nothing but a projection on a x cap. So it can be done in two ways. All vectors perpendicular to the column space lie in the left null space. One thing we know this, all vectors, that is first thing, all vectors perpendicular to the column space lie in the left null space. Thus the error vector E equals to B x x cap, that x cap must be in the null space of A transpose. So you have when if they are orthogonal, or if all the vectors are perpendicular to the column space, then automatically they appear in the left space, because you know the column space and left null space are orthogonal to each other. Hence the error vector must also be in the null space. Okay, and next point, how do you find out is that, that is this already, that is A transpose, and the error should be equals to 0. If I expand that, I'll be getting A transpose A x cap equals to A transpose B. So B is nothing but A x. So A x cap here. So the error matrix must be perpendicular to each column. So the error matrix, that is AX, should be perpendicular to each column. So you can have A1, if you have n vectors, so you have A1 to AN, they should be perpendicular to each of the vectors. This itself means the same thing, but you can have the whole matrix A1, A2, A3, sorry, the whole of the vectors, and multiplied with b, that is error, should be equals to 0. That indicates they are perpendicular to each other. So this is, one is null space A transpose B. You can see A transpose and the error vector should also be equals to 0. So you have A transpose B equals to A transpose A x bar. So A transpose, and what is B? B is A x cap. Square coefficient matrix A transpose A is fundamental matrix known as normal equations. They are called as normal equation. A transpose multiplied with the A in statistics. So here we can here when the Ax equals to B is inconsistent, that is when you don't have solution, you can solve it by using a least square method that minimizes the error. The values of x is approximately nearer to the that is what so that they solve all the expressions. So they satisfy all the expressions nearer to the equations. So normal equations are A transpose A S cap equals to A transpose B. So some of the points you can note down is that A transpose A is invertible. So it can be inverted exactly when the columns of A are linearly independent. If all the columns of A are linearly independent, then we can say that the multiplication of A transpose into A leads to the invertible matrix. You can that is you get an inverse of that matrix. Best estimate is you can have this as x cap. A, in the previous equation, that is from this itself you can write the x values. What will be x cap from this equation? A transpose when they are invertible. So this can be written if this point is invertible. If this matrix is invertible, then x cap can be written in terms of this inverse of this A transpose B. So same thing is written here. You can see the equation A into A transpose A inverse A B. So P into X cap. So this is projection. So it is nothing but how you are projecting the P equals to AX. So that it should be equals to your B. So you are projecting B onto the column space. And here you can see the X cap. And this is your A transpose and A B. You had something like equation A transpose A, that is x cap equals to A transpose B. So I told you this is invertible. So you have what x cap equals to this one. When it is invertible, only when the columns are independent to each other. And if they are orthogonal, they will be independent to each other. So here we have certain remarks. Suppose B is actually in the column space of A, then it is a combination of B equals to AX and of the columns, then the projection of B is still B. That is when you have the solution for the equations, automatically B will be equals to AX and B is still B. It is not the nearer value of B, it is the exact value will be getting. That is the solutions are consistent. So you have P equals to be in the column space. What will be the projection? Projection will be this. So when I will try to solve that projection itself, it will be equal to here A transpose A inverse. Here you have A transpose A and here A transpose A inverse. So what will be this value? This value whole together will be equals to I, right? A transpose into that, and that is X and X transpose, or A into A transpose. It is of that manner. That's the identity. A into I gives you A. So AX equals to B. So the B is still in the projection within the column space. Second remark is that at the other extreme, suppose B is perpendicular to every column, that when you are, the solution is inconsistent. So A transpose B is equals to 0. It appears in the column space, or you can say left null space. In that P projects the 0 vector. Instead of B projecting the columns, here it represents the left null space. So that is P equals to this. We can check this. So here you have A transpose A, that is I am writing this A transpose B equals to 0. I have expanded that. What I will be getting? A transpose A inverse A transpose. I will be writing it as whenever you have inverse, just change the place of these two. A transpose A inverse equals to A into A transpose, that is A.